I'm going to talk about responsible AI as cultural transformation from the perspective of Henning Larsen. If you don't know Henning Larsen, I have a few slides on that in a bit. But just about me, I'm an architect. I don't know how many architects you have who've been here or presented here, but I'm an architect in my training. I did my master's in Denmark, and now I'm pursuing what's called an industrial PhD together with Henning Larsen. Henning Larsen is a large architecture office that's based in Denmark, but is actually working worldwide and has global offices, together with the Royal Danish Academy in Copenhagen. So just about Henning Larsen. Henning Larsen is a relatively old firm in the kind of, the scale of time that you talk about architecture offices. It's from 1959, has projects in over 30 countries, offices in, I think, 9 countries by now. And now it's a little bit less, maybe than 650 employees. But we are big enough, so we work across different scales. We work in architecture, landscape, urbanism. We also do some interior work, and we also do some planning work. And the kind of guiding principles for Henning Larsen, first of all, is sustainability and circularity. This is something that's discussed to different extents in different geographies. I can tell you that in Denmark it's very big, and the office has kind of put it on its flag to focus on sustainable design. Design excellence, again, this might be a very Danish thing, but I think it's also kind of across architecture. We work towards making excellent, nothing short of excellent design. And one thing that maybe sets us apart from a lot of other offices is that we work a lot with research and data. Data is a complex thing to address that I'll address a little bit later, but we have the largest research department from all Danish offices for sure, potentially from all of Northern Europe, maybe even all of Europe. We have 6 PhDs, including myself, and we integrate a lot of research work into our daily work and our design processes. So an industrial PhD, that is very unique to Denmark. It's something that's trying to get the best out of the both of the worlds of practice on one side and academia on the other side. And when I say best of both worlds, we're trying to capture the rigor of academia, of actually looking into things and having, let's call it empirical evidence and research behind decision making, which is sometimes lacking in practice, but also having the relevance of practice, which is in many cases lacking in academia. So I'm trying to be somewhere here. But I'm also working in another overlap space, the one between architecture and urban design and AI, artificial intelligence. Just kind of an overview of my research. The research is not just focused on AI. It's actually grounded in what's called regenerative urban design, which is a practice that requires a very deep site analysis, which includes a lot of work with urban data. And what my research is focused on is how can we potentially use AI in order to better understand a site and better work with urban data in order to potentially achieve regenerative urban design. But if I'm looking at AI, when I joined Henning Larsen roughly 2 years ago, there was a lot of conversation around AI. There was a lot of hype. My initial proposal was about, actually, it was about regenerative design, but the office was like, you have background in computation. Maybe you can look into AI and find out what is it that we can do as a company in order to be more aligned with what's happening in the world, and how do we make use of this basically crazy technological revolution that is happening. And the first thing that happens in a lot of European companies is going into this world of governance, of saying, okay, this is a tool, we want to use the tool. How do we make sure we don't get sued? How do we find the right legal framework to work within AI? How do we make the right kind of guardrails around what is allowed and what is not allowed in order to just be on the safe side and then just roll with it? But what we identified very quickly in Henning Larsen is that looking at governance is not entirely a dead end, but it's a very slow-moving elephant. And it doesn't capture the entire essence of that is encompassed within working with AI. There's essentially many things that are not governable within the usage of AI. And that's why we are focusing more on this idea of developing an AI culture inside the office. But then why focus on culture? As I mentioned, there's a lot of aspects about AI that are not directly governable, and there's a lot of questions that are much more individual questions and ethical questions than they are questions of governance and kind of guidelines and rules and guides on how to use AI. And the conversation is once you go like basically one layer deeper than talking about a tool, you find out that the real conversation around AI culture is not about AI. It is actually about data. AI is merely a channel for using data. It is, in its essence, developing all of these kind of statistical ways to create pretty accurate predictions based on data, be it the data that it's trained on or data that it is fed in the process. But it makes it much more accessible and approachable to work with data. But there's also a lot of dangers that come with this. We talk in architecture a lot about data-driven design because this is kind of a big, let's say, weight that the industry is putting on us. We're making a lot of decisions that we need to defend because they cost a lot of money. And clients are tending to ask us, okay, you want to make that move? Show me the data behind it. And this is something that's happening in a lot of other sectors. But when we're talking about architecture, data is not the only thing that comes into play when we're making decisions. First of all, is because of the time frame. We're planning in very long time scales. Sometimes we plan something now that might be, realized in 20 or 30 years, and definitely not in exactly the same conditions, or even not in the same way that we planned it. So we need to make a lot of predictions, and we already know, at least people who work with data, I assume some people here work with data. The data is not something that you can have about the future. It's something that you can predict, is something that you can simulate, but it's very different than data that you collect. And then another thing, the data that we use, especially, there's different ways of understanding this term data. It's a very cryptic term, but AI essentially works with digital data. And there's a lot of aspects of architecture that are not directly translatable into digital numerical data. For example, I go into a room and I'm like, this room feels very open. And I go to another room and this feels very cramped. Those things are not, this is open 8 out of 10, and this is cramped 4 out of 10. There is no way to put numerical kind of calculatable data or learnable data on those things, but they are extremely valid considerations that we have when we work with architecture. So what we actually do is not data-driven design, but is data-informed design. Data is informing our design decisions together with a lot of other things like tacit knowledge, like human connections, like feelings, like intuition, like style, and all of these things work together with data. So it's much more about having a data-assisted design. And AI, even if we treat it as, if we treat the raw data as kind of truth that we can rely on, AI in itself is not objective. And the data sets that AI is trained on, they largely reflect what is popular, available, and visible online, and they're not equivalent to impartial coverage of the real world. Where does this apply in architecture? Actually, in many, many cases. But if I'm looking at the example of image generation models, they're trained on a huge amount of images, hundreds of millions. Some of them are images of architecture, but it is not trained on every building that has ever been built with a photo taken from every angle in every phase of construction, and is definitely not described in a way that is, let's say, we don't use a lot of empirical language. We use a lot of kind of elusive language to describe architecture. And when you're training a data set of images, you have to connect images to text in a very direct and empirical way. And the images that the architectural images that the AI models are trained on are actually coming from very specific places of the internet. They're coming from real estate websites, from design magazines, from social media. And they're definitely not covering every different possibility that exists within the kind of architectural spectrum. And therefore, when we're approaching the task of using AI in order to generate architectural imagery, and we're using language that is not empirical, but it's quite, I don't want to say cryptic, but it's open for interpretation. We use a lot of words like this building is very local, or this space is very inviting. Those things could be interpreted in different ways, but what I'm going to get when I'm using AI is what is statistically the highest probability of what that term means. And that probability is developed based on the database. So if I'm going to create an image and say, can you make an image of a beautiful building? I'm much more likely to get an image that looks like this than I am to get an image that looks like this. Even though there's a lot of people that would associate the word beautiful with that image. And there might be not even many people that associate the word beautiful with that image, but this one is what's represented online. It's way overrepresented. I think in the newer models, if you type beautiful, you're going to get this kind of pseudo-European looking villa. But this doesn't capture the essence of what this word means within architecture. And this is something that we have to take into account. Then there's a general kind of broader conversation about statistics. Statistics is inherently not taking into account whatever is missing from the statistics. So when I'm trying to make decisions within an architecture office, and then I'm going into AI to give me answers to certain questions, what I am expecting is statistical answers based on the data that it was trained on. But whatever data that is not there, is just not going to be represented, even though the answer could be very, it could sound very convincing. One example for this is this idea of what is the best song in the world. There is a statistical answer to that song, to that question. And it is actually a pretty strong claim to say this is the best song because it has the most likes and it has the most plays or the most views. But it's really hard to argue that this is actually the best song in the world. And this all goes to, I'm getting back to this, but this all goes to what is the meaning of how do we treat whatever output comes out of AI? How much weight do we give it in decision making? And this is, again, not something that is governable. This is something that has to develop through building up a culture of understanding how do we address AI. And what does it mean in our whole process of coming up with different decisions? Another example I really like is this example of autocorrect. Autocorrect is a very, very, very strong statistical tool. It has an incredible degree of accuracy in trying to give me suggestions to tell me what I meant when I wrote something. But we know that there's not a single person in the world that's going to write a 5-page document and then say, autocorrect send. Even though statistically it's going to probably make the right decisions, but not every decision can be decided only based on statistics. With architecture, we have all this terminology. I like to give this example of mullions. Mullions is a very architectural term. But statistically, 99.999% of the times where someone types in mullions, they actually mean millions because U is right next to I on the keyboard. But this is just not correct. So we cannot fully rely on it, and we cannot fully delegate decision-making into a statistical model. I also like to give this allegory of the chicken from Bertrand Russell. If you don't know him, look it up. He's talking about this chicken that lives in a farm, and one day the farmer comes in, and then he comes into the farm and he gives the chicken food. The next day, the farmer comes in again and gives the chicken food, and that happens again and again and again. What happens is the chicken develops a statistical prediction mechanism that associates the farmer coming into the farm and the farmer giving food to the chicken. So one day the farmer comes in, the chicken thinks, and rightfully so, I'm going to get food because this is what happens statistically 100% of the times. But what happened in that day is that the chicken became the food because the statistics was correct, but it did not capture the entire picture of what is happening. And when we work with architecture, we cannot isolate certain elements and just make decisions based on statistics of that specific element. We work in a much broader context that is not really capturable by either statistics or AI. Just to say that it's not that statistics are bad. There's a lot of different sectors where it's actually quite nice that they are based on statistics and they are very directly and let's say fully data driven. And one example is the pharma industry. But pharma industry have different practices of working with data. Whatever qualifies as valuable data in pharma is going through a lot of rigorous processes, and it's going through a lot of validation, and it's going through very controlled experiments into what qualifies as valuable data. And then that data needs to provide statistics above a certain threshold that only if it passes this, it will get FDA approval. No, there is no place, at least in modern medicine, where I can say, you know what, I'm actually feeling that in this pill, we should put 15% of that thing and not 10. I have to back it up with data, and I have to provide the experiments, and that's fine. But in architecture, we're not a purely data-driven practice, because if we were to be a purely data-driven practice, like they are in pharma, we would probably never make any handicap ramps. There's just not enough handicapped people to justify the amount of effort and time and money that is being put into making buildings accessible. But this is exactly the point where we don't really care about the statistics. It's interesting for me to know what's the percentage of people who have a wheelchair, and it might impact some of my decision making throughout the process, but this is not something that could make the decision for me or whether to do it or not. It's enough for me not even to have just one person on a wheelchair, but have one potential person on a wheelchair in the future for me to make that decision. And then there's another aspect of it, of different scales of optimization, statistical optimization, because if I have a city and every person in the city would go into AI and say, what is the best optimal business model for a restaurant? There is a statistical answer to this question. One that if everyone would follow, we would end up with a city that has multiple instances of the same restaurant, and then everybody's losing money. And also the city is becoming pretty boring. So statistical optimization is not even something that we aspire to, even if there was a statistical correct answer to certain questions. Another thing about culture is this idea of accountability. I like to give this example of Deloitte. Deloitte is not a small office. It's actually a pretty serious company, if you know it. And they got sued by the Australian government for providing a report that had quotes from papers that don't exist. And they have obviously used ChatGPT. Someone used it irresponsibly in a way that is, by the way, ungovernable. And they produced this paper with quotes that don't exist, and they got sued. Two interesting things about this. One is Deloitte got sued and not OpenAI. OpenAI and every other AI provider, they come with a little note underneath that says, by the way, ChatGPT can be wrong. By the way, double check. By the way, Claude can make mistakes. They completely take off responsibility from whatever output they are producing because they are probabilistic and they're not algorithmic. They're not performing calculations. They're not guaranteeing any type of truth. And this is inherent to the technology. This is not just like once the models get better. They will never provide this type of guarantee for the output that they're producing. But we maintain the accountability for the quality of the output. And this leads to the second thing. Not only that Deloitte got sued and not OpenAI, Deloitte didn't get sued for using AI. Deloitte got sued for producing a bad report. If I want to produce a bad report, I don't need to use AI. If I want to quote a paper that doesn't exist, I don't need to use ChatGPT. Trust me, I'm doing a PhD, so I know. But those two things, they just point out to the fact that using AI or not using AI is not really the thing. The main thing that we're talking about is accountability for the output. If I can guarantee quality output, whether I use AI or not use AI, it's not really the conversation. But being able to evaluate when to use AI and when to not use AI, and developing a culture in which I validate whatever I'm using AI for, and I'm taking full accountability for both the failures and successes of whatever I'm producing with or without AI, this is much more of a cultural thing than a governance thing. So how do we approach this at Henning Larsen, this whole more kind of theoretical thing that I've introduced? Well, the first thing that we do is that we take AI out of the ivory tower. There's a lot of companies, I know it's definitely happening in architecture, but it's also happening outside, where technology and technological advancements is kind of kept in the tech department. So there's a small group of people that sit up there on the ivory tower, and they learn how the technology works, and they decide for everyone else what is good for them and what is not. And a lot of those things end up translating into governance. So this small group of people who is not necessarily hands-on with a lot of the work that's being done at the office, they decide for everyone else what's good for them. But what we do at Henning Larsen is we take the opposite approach, where we do a bottom-up collective learning. We let everyone in the office be part of this AI transition and evaluate how AI can become beneficial for our firm. AI is not an architecture technology, it's an agnostic technology, and how it can be used for architecture is something that is to be discovered. It doesn't have architecture features, but it has some inherent properties that could be useful. What they are, nobody knows. A lot of people try to say, this is how you use AI for architecture, but the truth is nobody actually knows, and the only way to find out is to let people actually use it. And we also have this idea, I put the ivory tower on one side and the collective learning on the other side. We're looking at adoption of AI as both horizontal and vertical. So horizontal approach is like, what is it that could impact the entire company? What is it that everyone can use? And then everyone is part of that. And then there's also the deeper cases of, using agentic AI and using AI for code, and something that we actually don't see the entire office making use of all of this. And we do have people who are developing further in that direction. But this is kind of the two vectors of adopting AI into the office. How did we do this? We actually let the entire office, for a duration of 6 months, to use whatever AI tool they want. We told everyone in the office, choose whatever tool you think could be useful for you, and we will reimburse you for using the full version. Paid version is both safer in terms of data security, and also it gives you the full extent, so you can actually evaluate and not be limited by the free version capacity. And we let them use whatever they want for a month. And after a month, we just ask them to fill out this feedback form, where they tell us, this program that you've used, was it useful for you? What did you use it for? What are the upsides? What are the downsides? And we took those, and we've actually kind of isolated or pointed out some tools that we find very useful. And this comes from feedback from the employees. It's not from the tech department who isolated those programs. And for those who are interested, the ones that we are now using almost daily as Notebook LM, my personal favorite tool of AI, Claude as a GPT, and Perplexity for doing more elaborate web search and kind of, I don't want to use the word research because I'm a PhD, but let's say pseudo research. We also have our internal AI setup because Henning Larsen is part of Rumble, a bigger 20,000 employee consultancy, and they have developed their own internal chatbot that has some extra capabilities of accessing internal data. So it's a good kind of addition to all of those external tools. And on top of that, we've actually, I think it was signed maybe last week, and is going to be announced soon, that we're developing a strategic collaboration with CREA around the visual work of AI within architecture, where we're exploring that space together. We're informing them about how we are using it, and they're trying to slowly and surely improve the product in order to make it more useful for us. Because as I mentioned, this is not an architecture tool, but there are certain properties of this tool that make it very useful for us in architecture. So this is quite an exciting move that I hope more people will hear about soon. Our AI approach is based on 4 pillars or 4 foundational concepts: literacy, transparency, agency, and accountability. All of those things are the ability to impact those from a governance perspective is very, very low. But these are the ones that we focus on when we are adopting AI in the office. So literacy means that when we are training our employees to use AI, we don't teach people how to use tools, but what we teach is foundational concepts of AI. We teach people machine learning. We teach people what is an LLM. We teach people about pattern recognition and kind of probabilistic, basically educated guesses. What does it mean to turn words into vectors? What is a diffusion, pixel diffusion? All of those foundational concepts, this is what we teach, and we teach it to everybody. And then we say, now that you know those concepts, go and explore AI by yourself. Because honestly, teaching people how to use tools is one of the most redundant things, in my opinion, because tools, they change so much and so fast. And for people, if there's someone here who's generating images, then you can just see what happened to all the people who were experts in Comfy UI. What happened when Nano Banana was introduced? Suddenly, all of this knowledge about control nets and LoRa's and stacking and weights and whatever, all of this just became redundant because the new model came in and just made it possible to do with a 6-word prompt in a higher quality. But the foundational concepts, they don't change. Machine learning hasn't changed from the 60s. Transformers hasn't changed from 2017. And LLMs and image diffusion, all of those things, understanding those concepts, this is what we actually teach our employees, and we let them discover AI tools by themselves. Transparency is a mindset where we say we are always transparent about our use of AI, both internally and externally. And we need to be able to say whenever we use the AI, why we use the AI, what is the reason. If I don't have a good reason, if I'm being asked, maybe I haven't made a really good use of AI. But inside the teams, we are always open about saying, this is, I've used AI for this. This is what came out of AI. This is how I used AI. And this is why I used AI, but also in the way that we communicate with clients. Having a very clear contractual language with clients about AI prevents a lot of the potential problems around lawsuits and stuff that come from misunderstanding of like, whoa, you used AI, you didn't tell me. But also it becomes a strength of the office, because once you talk about AI from a position of knowledge, where you say, yes, I am using AI and I'm using it for this and this and this, and this is why, I'm not using AI here. This is why this task took me a week, even though your son can do it in a day. But I know what AI is and what is good for and what is not, and this is why I did it and it took long. And this is another thing. I have used AI, and that's why I can show you all of these images, in 24 hours. And yes, there's some kind of AI problems around it, but we know it's AI. So let's discuss the kind of essence of the thing. This becomes a very big strength that we have. Agency is twofold. One is about the agency that we give people around the testing and evaluating of whether they should use AI for, and whether they should use AI and what to use it for. But it's also about maintaining agency within design. When we're doing an architecture project, what we are actually paid for is to know the project very well and communicate it very well. And AI has this, we develop this tendency to delegate, give tasks to AI in order for AI to do it. And we all kind of lie to ourselves saying, no, I give it to AI, but I check everything. People who use Claude and ChatGPT, they can see it very clearly. Those cases where you let Claude write something, and then you say, no, of course, I read everything. I don't let Claude output just go directly into something. But after a while, you start reading a little bit less and kind of skimming through until you reach the point where you send out a text, and then someone asks you something, and you're like, when did I even write this? I don't even remember writing this. I don't know what this is about. We don't want to reach this with architecture. We don't want to reach a point where the client is like, why is this detail here? And I'm like, I don't know. I didn't even put it here. AI did this. So maintaining agency over design decisions, that's a big one. And then, of course, accountability, which is more of a mindset. A mindset of, I mean, I mentioned it before, but we are responsible for whatever we produce, whether we use AI or not. It doesn't matter. So these are the 4 foundational concepts of how we address AI at Henning Larsen. And now I have a few slides of how we use it at work. I'm going to skip through them very, very fast to reach the end of the presentation on time. But just to say, we're not generating buildings. We don't have, I mean, AI doesn't have this capacity. And even if it does, it's not going to be very good. And once it's better than me at generating buildings, then I should be looking for another job. But there's a long time before I can just prompt a building. But what we can do, architecture is not one task, designing a building. It's actually an orchestration of a lot of tasks. And we're not trying to eat the entire cake with AI, but we're trying to kind of break down architecture into different tasks and see where it can help us. One thing is, of course, day-to-day tasks, where we're using it in order to, we're using Copilot in everything around Microsoft, Excel, Outlook, Teams, looking through our own information, iterating, doing a lot of the business development work, evaluating different proposals in a way that is more streamlined. I have in those slides photos of the people on the side. This is just to show that all of the things that I'm showing today are things done by different people in the office. This is not our tech department who's doing some very cool stuff with AI. This is just, I don't want to say normal people because we have exceptional people at Henning Larsen, but this is a lot of different people in the office that are not kind of special trained in AI. All they were trained on are the foundational concepts, and they were just given the freedom to test things out. Definitely, we use it for communication. There's a lot of things that can be saved in architecture. For example, here the client said, I would like to have art gallery, a street art gallery in the parking lot. And Frank was able to actually create a lot of different iterations and show them to the client. Those things, they have sometimes quite a significant meaning in how we're going to plan the parking lot. And if I want to discuss with the client on what direction I should go to, and my only tool is to actually model all of these separately, communications become very slow and not very effective. But the ability to very quickly test things, even if they're not fully accurate, and align on vision before we go into production, that's very useful. Also, this from Martin, where this is a multifunctional space. And I mean, I don't know what a multifunctional space is. The client doesn't know. But Martin was able to very quickly kind of visualize different occurrences that could happen in that space. Philip, landscape architect, who was able to visualize different scenarios of flooding and how a little intervention could actually be impactful in terms of different flooding scenarios. Brian, who is taking very, very dry Revit drawings, turning them into very engaging and communicatable, whatever, however you say that, to show the clients also even in slightly more technical things and really align on the vision, even though he's more of a technical worker, but he has the landscape vision to know how this is actually going to look and feel like, and he can now do this with AI. We do a lot of work with data, and we're very careful about the work with data because of all of those things that I've mentioned before. But with AI, we can actually organize and map and visualize and structure the data that we have so that it's easier for us to navigate the data. So it's not just about drawing extracting knowledge and analyze the data, but it's just the fact that I can map visually what data do I even have and what does it say. Is something that is, it's impossible to say how much time this is saving and how much this is getting us closer to being more data-driven. This is also Brian doing some planting schedules. Of course, the world of visual expression, we're able to actually generate our own styles and then train our own models in order to then transition certain visualizations into a certain style very quickly in a way that was not possible before. We can show different scenarios from the project in a pretty consistent and engaging way, very, very, very fast. We can also show things in from a direction that's a little bit different. If we don't want to communicate all the kind of depth of detail that AI can offer us, we have slightly more abstract ways that we can very quickly, if we want to talk about massing, let's just show the mass. We can take very simplified and abstract inputs and make them into very engaging visuals very quickly. Again, this is not always the best thing to use if you want to make the kind of what we call a money shot or something that is highly representing what the project actually is, but aligning with clients and collaborators and stakeholders on intentions. This is something that is a complete game changer for us. Of course, testing different visual expressions of materials for different projects. But all of this is to say that one aspect of using AI in the office is when people are saying, okay, these are things that I'm already doing. These is processes that I'm already going through. How can I do it better with AI? How can I do it faster? How can I do it in a higher quality? But then there's this other aspect of saying, what are the things that I might have not been doing until now that I might consider to start doing? One of those things, I don't have an example here, but one of those things is video. I think that's a really interesting one because architecture doesn't exist as a frozen element. It exists in time. It doesn't exist only in XYZ, but also in the dimension of time. And the reason that architecture offices are not making a lot of videos is not because we had a corporate decision to not make videos because it's not the right thing. It's just because we're not animators. We don't know how to make videos. And if we want to take it externally, it just costs too much money. But now with AI, we're starting to explore a lot more kind of lively and including the dimension of time in some of the things that we're visualizing, whether it's the changing of the seasons, the movement of the people, night and day, different activities, wearing and tearing of materials. All of those things could be visualized in a much more engaging way. And we're exploring different ways to work that are not just directly an improvement of what we've been doing before. So what has been the impact of this approach that we've been taking, I would say roughly since mid last year? First of all, we're seeing a cultural shift. We're seeing the entire office openly talking about AI, openly trying out different things around AI, having a lot more confidence in talking to clients, in talking to each other, finding use cases and values in AI within the office almost every day. And one of the things, and this is also a little bit around communication, is we've started this digital community. It's Teams chat. And I don't know how many of you have Teams at work, but it's very rare that you have a chat that is not mandatory to partake in. And more than half of the company is part of that chat. And then we also have those bi-weekly quick sharing sessions where different people from the office are sharing different workflows and different success or failure stories with AI. And we have an overwhelming participation in this. We're starting to see a shift in some of the skills, what I would call new skills. Working in a prompting environment is a new skill. Validating and evaluating AI output is a relatively new skill. Modeling for AI, performing different types of searches and data validation. These are skills that were not part of the architectural toolkit, and we're seeing people becoming actually pretty good at this. And there's also starting to come in, we haven't done a full complete survey, but from the ones that we have done, we're seeing that tasks that people use AI for, they're saving, 70 to 80% of the time on average. Almost everyone across the board is reporting an increased quality. This is in the conversation about accountability. And we're also saving quite a lot of money. AI is relatively cheap. And the saving of time is saving money, but also saving on a lot of external services that we can internalize. So all of those things are happening and are being measured, but we're going to create a better report for this in the future. And some final thoughts. First of all, this binary thing of should I use AI or should I not use AI, this binary junction doesn't really exist. What actually we find that exists is something much more similar to a spectrum. When I'm given any type of task, whether the task is to create something visual or the task is to create some sort of text, I'm asking myself, or at least if I'm using AI correctly, I would call it, I'm asking myself, where is this task placed on that spectrum? Am I letting AI do it, but I'm just validating? Am I doing it myself and then I'm giving it to AI to give me some feedback? And am I sparring between myself and AI and say, what about this concept? Okay, let me change this, let you change this. Making the image, taking it to Photoshop, and I'm making the render. Like there's all those different placements of how much AI involvement should be in that task that I have. That also applies to the world of data, but I can't get into that in that conversation. But it's much more like this than it is like this. There is something about AI, and I've mentioned this before, it's an agnostic technology, and too many people are not realizing that this is a solution that's looking for a problem, that they are looking at like, what is my biggest problem right now? How can I solve it with AI? How can I make AI do this for me? And an analogy that I would use is, let's say I'm a carpenter and I like to build sheds. And my biggest problem, the things I hate the most, is to cut down the timber in the right size. I hate this task. It takes so much time. It's so inefficient. And then someone comes in and says, look, I have this new technology. It's an electric drill. If what I try to do is chop the timber with the drill, I'm going to find it very ineffective. I'm going to get frustrated. It's not impossible. I can try and install different things on the drill to make it do the thing that I do. But if I take a step back and I say, let's study the drill, let's understand how it works. What are the inherent properties of that? Maybe there's actually other tasks that can be solved with this thing. And finding the right problem is actually much more significant in efficient and effective adoption of AI than trying to solve pre-existing problems with AI. And the last slide for today is to say that one of our biggest understandings is that we're not in the journey to just kind of grasp and understand AI and then implement it in the work, but we're understanding that this is a never-ending journey of learning, always kind of having the heart, the hand on the pulse, and being in a continuous state of learning and understanding what AI is the goal. So whatever we're learning right now, we're constantly reevaluating, we're constantly exploring. We're not just trying to narrow down, okay, this is the tool, this is the model, this is the prompt, now let's get back to work. But we've entered this mindset of continuous learning, and it's been working out pretty good for us.